Hello students, today we are going to talk about another aspect of quantitative chemistry known as the mole. As you can see on the board, the mole. What do you mean by the term mole? You see, mole is a unit of measurement. If I have a unit of measurement, it's a unit of measurement in chemistry, in physics, in science generally. Mole is the amount of a substance. Mole is the amount of a substance that is having a unit, that is having a certain number of units. For example, if I have a cup of water now, I know water is H2O. There are so many H2O molecules inside that cup of water because a unit of water is a molecule of water, H2O. A unit of water is a molecule of water, H2O. If I trap a particular amount of oxygen, if I trap a particular volume of oxygen, gas, the unit there is O2 gas. O2 gas, that is one oxygen molecule. If I cut a particular mass of carbon or graphite, the unit there is carbon atom. So a mole is a particular quantity of this unit. For example, a mole of water will contain the same amount of H2O molecule, this is the particle of water, as a mole of oxygen will contain. A mole of oxygen will contain the same number of molecule as a mole of water. A mole of carbon will contain the same number of particles, this time atoms. A mole of carbon will contain the same number of particles that a mole of water contains. But this time around, this is the particle here is atom and the particle here is molecule, the particle here is molecule. As far as they are one mole, they contain the same number of particles. They contain the same number of particles. But the quantity that will contain this particle here may be different from the quantity that will contain the particle here. May be different from the quantity that will contain the particle here. Every substance. So the mole of every substance is the amount of that substance that will contain a particular number of particles. And this number of particles is known as Avogadro's number. Is known as Avogadro's number. This may seem a big name for you. Avogadro's number. H2O, one mole of H2O will contain one Avogadro's number. One mole of H2O contains one Avogadro's number. One mole of O2 contains one Avogadro's number. What is this Avogadro's number? What is this magic number, Avogadro's number? One mole of carbon will also contain one Avogadro's number. What is this Avogadro's number that is a magic number? That every substance, one mole of every substance contains that amount of particle. It has been calculated experimentally to be 6.02 multiplied by 10 raised to power 23. H2O, 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 H2O. 6.02 multiplied by 10 raised to power 23 of these molecules will be present in 1 mole of water. The same thing here, 6.02 multiplied by 10 raised to power 23 molecule of hydrogen will be present in, of oxygen will be present in a mole of oxygen. The same thing, 6.02 multiplied by 10 raised to power 23 atoms of hydrogen, of carbon, this here molecule, because molecule is the unit, here molecule, because molecule is also the unit. So atoms of carbon. So you will now see that how many of oxygen, how much of oxygen, what mass of oxygen, what volume of oxygen will contain this is a different thing entirely. What volume of oxygen will contain that is a different thing entirely. What mass of oxygen will contain that is a different thing entirely. What mass of carbon will contain that amount is a different thing entirely. So the mass of carbon that will contain 6.02 times 10 raised to power 23 atoms of carbon is 1 mole of carbon. And the mass of water that will contain 6.02 times 10 raised to power 23 molecules of water is 1 mole of water. And the mass of oxygen that will contain 6.02 times 10 raised to power 23 molecule of O2 is 1 mole of oxygen. For all substances, the amount of that substance that contains 6.02 times 10 raised to power 23 of the particles present in that substance is what? Is the mole of that substance. A mole is defined as the amount of particle of a substance, the amount of a substance, as the amount of a substance which contains 6.02 times 10 raised to power 23 particle of that substance. The particle may be molecule, it may be atoms, and it may be ions. It may be particle, it may be atom, it may be molecule, it may be ions. So how many grams of carbon will contain 6.02 times 10 raised to power 23 atoms of carbon? That amount is a mole of carbon. That amount is a mole of carbon. Then I can now write the definition of a mole. Do you understand this explanation? Now let me now write the definition of a mole. The mole of a substance is defined as the number, as the quantity of the substance which contains which contains 6.02 multiplied by 10 raised to power 23 particle of that substance. A mole, the mole of a substance is defined as the quantity of the substance which contains 6.02 times 10 raised to power 23 particles of that substance. Please write this down. This is the standard definition of a mole. The mole of a substance is defined as this. Now, let us now look at the formulas of mole. The mole has several formulas. It has so many formulas, but for your level, we will take just some of them. And we shall do that now. I will clean the board here now. Now, the mole, I will start with the first formulas. My first formula here is the mole and mass. Mole and mass. Okay, mole and mass of a substance. Okay, mole is given by, is represented by letter N, small n. So N, number of mole equals to given mass of a substance, given mass divided by molar mass. Molar mass is the same thing as relative molecular mass, molar mass. Or mass of 1 mole, or want to say mass of 1 mole. In some exams, they'll just tell you mass of 1 mole. So we write it normally as given mass as small m and molar mass as big MR. So if you see that mole is N equals to, I write this in words, number of moles so N equals to M, small m divided by big M R. Now, I am going to give you some examples. I have already selected some questions for you, and I've written them on the board before we start the class. So let us go back to my page 11. Now, I say calculate the number of moles present in the following substances. 4 grams of hydrogen, 4 grams of hydrogen, 4 grams of hydrogen, 4 grams of hydrogen, 4 grams of hydrogen. How many moles do you have? Write this formula down. Write this formula down. Write the formula down. This is the first one. First formula. Mole and mass. So the mole is number of mole is given by mass small m over molar mass. Now I now ask you, in my first question, calculate the number of moles present in the following substance. Okay, 4 grams of hydrogen gas. 4 grams of hydrogen gas. This is the deliberate 4 grams of hydrogen gas. Okay, N equals to M given mass over molar mass. What is the molar mass of hydrogen? You remember when I was treating empirical formula, I considered when I was teaching empirical formula, I only looked at the atoms. I did not look at the mole. I looked at the atoms because it is the simplest simplest ratio we are looking at. So now we are looking at mole. A mole of hydrogen contains what unit? H2, because hydrogen is a diatomic gas. Hydrogen is a diatomic gas. So I will look at periodic table. I will look at the periodic table and I'll look at hydrogen. The mass of hydrogen is 1, but the molar mass of hydrogen will be 2 because I have 2 atoms of hydrogen in 1 mole of hydrogen. So my answer will be, and my M given is 4 grams. So, and the mole of hydrogen, molar mass of hydrogen is supposed to have 1, but it's H2, that makes 2. So my answer, my N here will be M, which is 4 divided by 2, which is equals to 2 moles. 2 moles. This is 2 moles. 2 moles. I have 2 moles of hydrogen because the given mass is 4 and the molar mass of hydrogen is 2. The molar mass of hydrogen is 2. Can you see that now? All right. Now, let's go down again and look at another one. I deliberately gave you some diatomic gases. 16 grams of oxygen gas. 16 grams of oxygen gas. Yet again, oxygen is a diatomic gas. So oxygen is a diatomic gas. Whatever you see in the periodic table, you have to multiply it by 2. You have to multiply it by 2. You have to multiply it by 2. In the periodic table, whatever you see there, you need to multiply by 2 for oxygen because it's a diatomic gas. Oxygen here is 16. But 1 mole of oxygen has a number of molecules. You say the unit is O2. The unit is O2. The unit of oxygen is O2 because it's a diatomic gas. So I cannot use 1. I will use 2 multiplied by 16. Do not forget this. For diatomic gases, the number of mole, if you are using the number of mole, the mass you see in the periodic table, you need to multiply by 2. If it's a triatomic gas like ozone, ozone is O3. So you will use times 3. Okay, let's go. Now, I said 16 grams of oxygen. So N again is given mass divided by molar mass. The molar mass of oxygen is 32, which is 16 times 2, because O2, which is equals to, I have 16 there on in the periodic table, times 2, which is 32. So, what is my given mass? In my question, I have been given 16 grams of oxygen. So, I have 16 divided by, what's the molar mass? 32, because it is what? Diatomic gas. Whatever I see in the periodic table, the upper part of the periodic table, I will multiply by 2. So this gives me 0.5 moles of oxygen. Okay, let me look at ozone. The third one is ozone. The third one there is ozone. 32 grams of ozone. Ozone gas is a triatomic molecule. It's a triatomic molecule. So I have 3 times 16 there. 3 times 16. Again, I will use the same formula. I have given mass. I've been given 32 grams in the question, and the molar mass is, since ozone is O3, ozone has O3, which is 1 oxygen is 16 multiplied by 3, which is equals to 48. So the molar mass of ozone is 48. I have 32 divided by 48. This is 32 divided by 48. 32 divided by 48 gives me 0.6666 mole, which is 0.67 moles. This gives me 0.67 moles. Now, let me shift again. Let me go to 63.5 grams of iodine. 63.5 grams of iodine. Iodine is 127. 127. Iodine is 127, and I want to look for the number of mole in 63.5 grams of iodine. 63.5 grams of iodine. I use the same formula. N equals to M over MR, which is equals to 63.5 divided by 127. This gives me, this divided by this is 1 over 2, which is 0.5 moles. You can see this thing is very easy. It is really easy. I am not going to answer everything. 23 grams of sodium, you can answer that by yourself. But let me answer this. 1 ton of aluminium is really large. We use ton especially when we are extracting metal. You imagine we have lots of aluminium ore. You will know about this later. From the ground, we got from the ground, from the earth, then we are trying to get aluminium from there, and we got 1 ton of aluminium. I want to know the number of mole of 1 ton of aluminium, number of mole in 1 ton of aluminium. So 1 ton of aluminium, you see, when you have 1 ton, you know a ton equals to 1,000 kilograms. A ton equals to 1,000 kilograms. If a ton is 1,000 kilograms, 1 ton equals to 1,000 kilogram. But we do not want our answer in, we do not want to calculate kilogram. In chemistry, we normally calculate in grams. So we convert this to grams, we multiply it by another 1,000, because how many grams make 1 kilogram? In every kilogram you have how many grams? 1,000. So this will be equals to 1,000 multiplied by 1,000 grams. This is 10,000. 1, 2, 3, 4, 5, 6. So 1 million. 1 million grams of aluminium. So the mass of aluminium here is 1 million. And my N equals to M divided by MR. What is the MR of aluminium? I go again to my 4-figure, my periodic table. I go to aluminium. What do I see there? 27. 27. So 1 million, 1, 2, 3, 4, 5, 6 divided by 27. 1 ton is 1 million gram. 1 million, 1, 2, 3, 4, 5, 6. Oh, too much. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 divided by 27 equals to 37,037 moles. 37,037 moles. 37,037 moles. So that is what we have here. 37,037 moles. So this equals to 37,037 moles of aluminium. So first I converted to grams. So so this is the number of mole. So this is the amount of grams in 1 ton. You understand it? Now let's go to another area, another formula. So that is the first formula. Another formula of mole, the second formula of mole is mole, number of mole equals to number of particles. Number of particles. Particles may be atom, it may be ion, and it may be molecule. Divided by Avogadro's number, 6.02 times 10 raised to power 23. 6.02 times 10 raised to power 23. So we want to look at it in terms of the number of particles there. In terms of the number of particles there. So let's look at it in terms of number of particles. So let's take some examples. Calculate the mass. Oh, I didn't do this. Calculate the mass of 0.2 moles of potassium. Before I go on, please let me quickly do this. And 2 moles of sodium, 0.2 moles of potassium. Calculate the mass. I've been asked to calculate the mass. I know that N equals to M over MR. I've been given M to be what? I've been given M to the 0.2 moles. 0.2 equals to, I don't have the mass, and potassium is 39, I guess. Potassium is 39. Potassium is 39. Potassium is 39 divided by 39. I'm looking for mass. What do I do? Mathematically, I cross multiply to get this. This multiplied by this. So I have 0.2 multiplied by 39 to be equals to M. And 0.2 multiplied by 39 is what? 0.2 multiplied by 39 equals to 7.8. 7.8 grams. 7.8 grams. So I have 7.8. The answer must be in grams. Also, mass of potassium in 0.2 mole of potassium. You can see that now. Okay. Again, 2 moles of sodium chloride. You should be able to do that. So let us now look at another formula. Number of particles divided by Avogadro's number. So we have 1 mole of a substance weight is, what is the weight of 1 or mass? I should put this one, you can do it yourself also. Now, this one you can do it yourself. Still about mass. If we have time, I'll come back to this. What is the mass? I will not put weight there. That is a misnomer of 1 mole. Okay, if we have time, we can come back to mass. Our romance is over the mass, but if we have more time, we come back to it. So let's look at number of particles. Calculate the number of particles present in the following. Calculate the number of particles present in the following. 0.1 mole of water. 0.1 mole of water. 0.1 mole of water. Before I do that, let me do number 5. Calculate the number of moles of this. Calculate the number of moles of 6.02 times 10 to the power 24 molecules of water. Calculate the number of moles in, I want to know the number of mole and in number of particle. How many particles do I have there? 6.02 times 10 to the power 24 molecules of water. That is the number of particle. The particle here is molecule of water. 6.02 times 10 to the power 24. I'm looking for the number of mole. So it has to be divided by what? According to our formula, 6.02 times 10 to the power 23. So 6.02 times 10 to the power 24, 6.02 times 10 raised to the power 24 divided by 6.02 times 10 raised to the power 23 equals to, oh, there's a mistake somewhere. 6.02 10 raised to the power 10 raised to the power 23 divided by 24, sorry, cancel. Anyway, if you calculate this mathematically, you are going to get 10. What you get here will be 10 because this is the same. I cancel this one out. I cancel this one out. I have 10 raised to the power 24 divided by 10 raised to the power 23, which is equal to 10 raised to the power 24 minus 23 from your indices. So this is equal to 10 raised to the power 1. 10 raised to the power 1, which is 10. So your answer is 10 moles. So N is 10. I have 10 moles of what? What is the substance again? 10 moles of number 5. 10 moles of water. 10 moles of water is present in this number of molecules of water. So 1 million atoms of sodium. 1 million atoms of sodium. 1 million atoms of sodium. How many moles in 1 million atoms of sodium? The particles there are atoms. So N equals to number of particles 1 million. 1 million divided by 6.02 times 10 raised to the power 23. This will be 1 million divided by 6.02. 1 million 1, 1, 2, 3, 4, 5, 6. I always have it more. 1, 2, 3, 4, 5, 6. Divide by 6.02 times 10 raised to power 23, and my answer will be, there's a mistake somewhere. 1 million 1, 1, 2, 3, 4, 5, 6. Okay, divide by 6.02, which is the Avogadro's number, times 10 raised to power 20 equals to, that's a mistake. 1 million divided by this will not give me this. 1 million 1, 1, 2, 3, 4, 5, 6. Okay, divide by 6.02. Oh, okay. This 1, 1, 2, 3, 4, 5, 6. That's 1 million. Bracket close. Divide by 6.02. Okay. Multiply by 6.0. This is giving me problem. 1, 2. In my days, no calculator. I can solve this without calculator. 1, 2, 3, 4, 5, 6, 7. In my days, we have no calculators like yours. All this raised to power, we use 4-figure table. Okay, bracket close. Divide by, again bracket open, 6.02 times 10 raised to power 23, bracket then closes. This is equals to, aha, now I have the answer. Okay, 1.66 times 10 raised to power minus 18. 1.66 times 10 raised to power minus 18. Okay, solving it my own way, I will just say 1 divided by 6.02 times 1, 2, 3, 4, 5, 6. 1 times 10 raised to power 6 divided by 10 raised to power 23. It's done. So I have 1 divided by this. 1 divided by 6.02, it gives what? 0.16. 0.16 giving 0.167. Giving 0.167, I will say 0.167 times 10 raised to power 0.167. 0.167 times 10 raised to power, this 6 is up, this is down, this one goes up, it becomes minus 6 minus 23. So I now have 0.167 times 10 raised to power minus 17, or I take this one here, it becomes 0.167 times 10 raised to power minus 17 moles. It's easy. It's easy. It's even easier to solve it like this than your calculator giving me problem. I am not used to these things. Now, this is the number of, okay. Now let's now look at number 4. Let's now look at number 4. Let's now look at number 4. Calculate the number of particles present in the following. Okay, 0.1 moles of water, 11.5 grams of sodium. You should be able to calculate this using that formula now. Let's go to another formula before we call it a day. Let's go to the last formula before we call it a day. Let's go to the last formula before we call it a day. Number of mole again. This time around, we are not talking about particles. We are not talking about mass. We are talking about mole and molar volume of gas and molar volume of all gases. We find out that all gases, be it hydrogen, oxygen, nitrogen, chlorine, fluorine, carbon dioxide, even if it is steam of water, as far as it is a gas, all gases at room temperature and pressure, RTP, occupies 24 dm cube. All gases, 1 mole of every gas, all gases at room temperature and pressure occupy 24 dm cube. Or 1 mole of all gases, or of every gas, let me write that, 1 mole of every gas occupies 24 dm cube. 24 dm cube occupies 1 mole of every gas occupies 24 dm cube at room temperature and pressure. RTP. But 22.4 dm cube at standard temperature and pressure STP. At room temperature and pressure, 1 mole of every gas occupies 24 decimeter cube, but at standard temperature and pressure, it occupies 22.4 dm cube. Please, if you are giving your volume of the gas in centimeter cube, you need to convert it to meter to dm cube by dividing it by 1000, because 1000 cm cube makes 1 dm cube. Okay, let us now look at some. Please write this down. This is very important. For your level at IGCSE, you are only going to get room temperature and pressure. That's 24 dm cube. But at A level, AS and A2, you may get this and you may get that. So write this down now. So if that is the case, we can now write the formula for 1 mole. Formula for 1 mole of every gas, 1 mole of every gas, and will be equals to the number of mole of every gas will be equals to volume, given volume in dm cube divided by 24. Given volume in dm cube divided by 24 dm cube. That's given volume divided by 24 dm cube. So the given volume of gas we have, let's take some examples. Okay, calculate the number of moles of the following gases at room temperature and pressure. At room temperature of pressure, 6 dm cube of nitrogen. 6 dm cube of nitrogen. I go back to my page. 6 dm cube of nitrogen, the number of mole, N equals to 6 divided by 24, which is equals to what? 6 divided by 24 is what? 6 divided by 24 is 1 over 4, 0.25, 0.25. so which is equals to 0.25 moles. You see how simple it is. As far as it is a gas, it must be this formula. The volume you are given, you divide by this. Okay? Now again, another one. 240 cm cube of hydrogen gas. 240 cm cube of hydrogen gas. 240 cm cube of hydrogen gas. Okay? 240 cm cube of hydrogen gas is the same thing as 240 divided by 1000. 240 divided by 1000. This is 0.24 dm cube. 0.24 dm cube. 0.24 dm cube. 240 divided by 1000. 0.24 dm cube. So the volume I will use now is 0.4 dm cube. That means I have number of mole equals to 0.24 divided by 24. This is what? 0.01. 0.24 divided by 24 equals to 0.01, equals to 0.01 mole. You can see how simple it is. Any gas at all, any gas at all, any gas at all. Now, calculate the volume of the following: 0.2 moles at RTP, 0.2 mole of carbon dioxide, 0.2 moles of carbon dioxide, 0.2 mole of carbon dioxide. Now we have been given the number of moles. 0.2 equals to, we are looking for volume, divided by 24. So what do we do? Math students, cross multiply, and you get V equals to 0.2 multiplied by 24. V then equals to 0.2 multiplied by 24, which is equals to 4.8 dm cube. As simple as ABC. As simple as ABC. So it's so easy. Another one, it says 0.5 mole of SO2. You can do the same thing and you get your answer. So let us now look at I did not solve some. You need to go back and solve them. I am very interested in this because I have combined more than one thing, one formula. In this, I've combined more than one formula in number. Today, I defined the mole for you, that the mole is defined as the amount of substance which contains 6.02 times 10 raised to power 23 number of particles. These particles may be atoms, may be ion, and may be molecule. And I gave you three formula. The first one, mole and mass. Mole as mass, number of mole as mass, given mass divided by molar mass. We solve some questions. I still have some unsolved there. You go back there and solve them. Two, I gave you mole, number of mole and number of particle. I said number of mole equals to the amount of number of particles you have in that substance divided by the standard, which is 6.02 times 10 raised to power 23, Avogadro's number. And the last one I gave you is that of gases. The first two is for everything, but the last one I gave you is that for gases alone. All gases occupy at room temperature and pressure 24 dm cube, or at standard temperature and pressure 22.4 dm cube. So we have the formula that number of mole of gas equals to the volume given to you, which must be converted to dm cube, divided by 24 at RTP and 22.4 as at SDP. Now let's look at Number 8 question, which I like so much. What is the mass of 6.3 times 10 to the power 5 atoms of lithium metal? What is the mass of this? With this, I can get the number of mole. After getting the number of mole, I will now use the number of mole and the molar mass of lithium to get the mass of lithium. So first, let me get the number of mole. I know I'm looking for mass of lithium, and I know the equation linking mass and number of mole is N equals to M over Mr. Mr, molecular atomic mass, or Ma. I can get it since it's an atom. I can get it from the periodic table directly. Then the mass is what I'm looking for. For me to get the mass, I need to know the number of mole. And for me to know the number of mole, I can use this. So I can say N equals to 6. That is number of particle divided by 6.2 times 0.2 times 10 raised to the power. So I have 6.3 times 25 times 10 raised to the power 25 divided by 6.02 times 10 raised to the power 23 is the number of mole. Please let me use my own method. Your calculator is disappointing me. 6.3. I wasn't brought up that way. Multiply by all the 10. There's 10 here, there's 10 here. I choose 110. This is 25 here, up here. I put it there. And this one, when I take it up, it becomes minus 23. So I have 6.3 divided by 6.02. 6.3 divided by 6.02 equals to 1.05. 1.05. That's 1.05. 1.05. So I have 1.05 multiplied by 10. 25 minus 23 is 2. So I have 1.05 times 10 raised to the power 2, which is the same thing as 105. 105 moles. I have 105 moles. If I have 105 moles, it is not mole I'm looking for. It is mass I'm looking for. Do not forget, I use two formulas here. N equals to number of particles divided by Avogadro's number, which is 6.02 times 10 raised to the power 23. I first use this one. I use this one to get the number of mole first. Okay, which is what I've just completed. Now I want to use this one to get my mass. Okay, now I want to use this one to get my mass. Can I clean this? Write it down. Pause your computer. Pause the video and write this. Then I'm cleaning it now. I got my answer as 105 moles. I can now say 105 equals to mass divided by what is the atomic mass of lithium. Lithium is 7. Lithium is 7. So divide by 7. So M equals to 7 multiplied by 105. 735 grams. 735 grams. This gives me 735 grams of lithium. Okay, so you can solve this one. This is volume of gas. You can solve this volume of gas. You can solve this. You can solve this volume of gas. Not volume. What you do here first, you use this. I'm looking at the volume of gas in this. Use this and this formula to get the mole. You know the mass, and molar mass of Cl2 is 35.5 times 2. Put it here. Cross. You now get the number of mole. You know the mass. You know the molar mass. 35.5 multiplied by 2. You get. When you get N, you go to the other formula. Sorry. You go to the other formula because it's a gas. and I'm looking for volume. You see, N equals to volume divided by 24. Already you got N, and you cross multiply, and you get your number of volume. You get your volume. Number of atom is 230 grams of a metal. Use the first one also to get what? To get your mass, to get your number of mole, and after that you now go to this is where we will stop today. The ones I have not solved, go back there and solve them, and we will continue from here in our next class. You understand the three formulas. Formula involving mass, that is number of molecules to mass divided by volume, and the other two formulas. Okay, this is where we stop today for both IGCSE student and AS student. It's a common topic. It's just that we need to dig further for AS student. Good day and God bless.